It was good. So today you got a quick question on electrochemistry. Today we're going to be doing electrolysis. So yeah, let's just get into it right now. So chlorine gas is produced from the electrolysis of molten sodium chloride over a period of 1 hour fills a 50-liter container at 25 degrees Celsius and 2.4 atm atmosphere. Calculate the intensity of the constant current used for electrolysis. So we're looking for the intensity. That's going to be I. First, maybe I'll explain like what equations we're going to use. So with electrolysis, there's only like a limited number of wait, let me just pull up my data sheet real quick. I forgot to formula sheet. Okay, yeah. So what equation we're going to be using is Q, which I'm 99% sure is charged because I literally learned this like 9 hours ago in class, is equal to intensity times time, which is also equal to moles of electron times Faraday's constant. So in this case, we're not going to be using Q, but we need to find this, I, that's the question mark. We know time. We don't know moles of electrons yet, but we can find that, and we also know Faraday's constant. So yeah, the first thing is we need to find the moles of electrons. How are we going to find the moles of electrons? Well, we could do that by finding the moles of chlorine, and that'll be shown in this kind of equation here. If we first write the half reaction, so chlorine gas is produced, so Cl minus goes to Cl2. So we have to balance it out. So we got two negative charges on the left side, so we got to add two electrons to the right side so that the charges are balanced. But this is the half reaction that we're looking at. And now we could establish a relationship between the moles of electrons and the moles of Cl2. So if we could just find the moles of Cl2, multiply that by 2, and then, okay, wait, that sounds like a tongue twister. But if we can find the moles of Cl2 produced, and then if we just multiply that amount by 2, we'll have the moles of electrons. And then we could substitute that right into here. But we need to find out the moles of Cl2 first. Now, what equation are we going to use to find out the moles of Cl2? It doesn't say anywhere, but we're going to be using PV equals nRT. In other words, we're going to be using the ideal gas law. So just isolate for N. So for moles, I mean PV over RT. Okay, so now we're just going to substitute all these in. Pressure is 2.4 atm. I'm not going to change it because that's a lot of work. So, wait, isn't that the standard? Wait, what's the... What? Oh wait, I have the other value here, so we could just use this one. Volume is 50 liters over, what's the value? 0.0831, no, 0.08206 liters times atm divided by moles times Kelvin. And now we have to use Kelvin rather than degrees Celsius, so we're going to add 270, what is it, 273? Wait. Well, why am I blank? 278.1. 298. So we're going to add 273.15 and we're going to get 298.15 Kelvin. Okay, now we're just going to substitute this into our calculator. Where's my calculator? This is my backpack. One sec. Wow, I got to work on like my organization, bro. I just throw everything in my backpack and just hope it goes in. And hopefully I just pray I find it. Okay, so the value we're going to get is 4.9 moles. Mind you, this is going to be 4.9 moles of Cl2. So now here in this reaction here, we have 1 mole of Cl2 and 2 moles of electrons. So for 1 mole of Cl2, we're going to get 2 electrons. So if we have 4.9 moles of Cl2, we got to multiply that by 2 moles of electron over 1 mole of Cl2. Cancel. And now what we're going to end up with is multiplied by 2, 9.81 moles of electrons. Now we substitute this into our, I don't even know what the name is. Is it a nernst equation or something? Let me find a name. That would be helpful. Yeah, well, there's no name. That's helpful. Okay. I think it's the nernst. I don't really know. Okay, so let's write this out. Okay, I'll just rewrite it. Okay, so what are we looking for again? Intensity. Ne, so 9.81 moles times Faraday's constant. C. Oh yeah, okay. 96485 coulombs, I think, per mole. Okay, so that's canceling out the moles, and then divided by time. Now, what is time? Well, we need to make time in seconds, and it's 1 hour. So hopefully you're able to do that conversion, but I'll just write it out. 1 hour. How many minutes are in an hour? 60 minutes in 1 hour. How many seconds per minute? 60 seconds per 1 minute. Units cancel. Therefore, if we just multiply it by 60 times 60, which is equal to 3,600 seconds. Now we put this into our calculator. If you watch Gumball, you would know why I said that. 49648 divided by 3600. 26.29 coulombs per second, which I'm 99% sure is the same unit as amplitude. Or I might just be giving you false information. Let me just look at my notes real quick. Yeah, moles. Yeah. I guess that's the same thing. 262. Yeah, we got. Wait, hold on. Why am I getting 269? Oh, I forgot to. Oh, I forgot to add another number. Whoops. This would be. Oh, I thought this was joules. I didn't write it the right way. Okay, that's wrong. 1 sec. My bad. Let me just redo this real quick. Multiplied by 96485 divided by 3600. 262 coulombs per second, which is basically equal to amp. So we're going to put 263 amplitude or coulombs per second. And there you go. That's our answer. So hopefully that made sense. The main, for me, what I struggled with the most was this step right here. The step of just getting the right electrons. I remember in lecture I was low-key confused about it, but I low-key understand it now as well. So pretty chill, bro. Yeah, that's all for today. I'll see you tomorrow. Goodbye.